Hi, my name is Kenny Nguyen. Today we're going to be talking about load testing gRPC services in Node.js. So who am I before we get started? So before we journey into this presentation, I just want to establish what drove us, me and the team, to create gRPSeek. It's a tool conceived through pragmatic exploration and analysis of the gRPC protocol. We used it as our sandbox, right, for studying and probing the nuances of gRPC. So while we gained knowledge through this journey, the overarching objective was to explore and understand the challenges that other devs may face surrounding gRPC and Node. So this is the team that created it. Miri's on the left, me, Patrick, Johnny. Miri's actually right there, hiding in the back. And then this is the new gRPC mascot. That's my dog, Charlotte. So today's agenda is why load test your servers, and then I'll introduce gRPSeek, the load testing tool that we created. Then I'll talk about some insights into development, followed by a quick demo. After the demo, I'll talk about some performance metrics. And then at the end, we'll do a Q&A. So why load testing? So load testing helps devs identify issues such as system lag, slow page load times, or crashes when different levels of traffic are accessing the app during production rather than post-launch. It can help you identify bottlenecks in your system. Knowing how your system performs under various levels of load can help you identify scale your services effectively. Also, if you had any made any promises in your service level agreements, these load tests can help you meet those guarantees as well. So what is gRPSeek? Like I said, it's a load testing tool. There are various aspects of performance testing, such as stress testing, network throttling, and so on. This tool just focuses on load testing. And some key metrics we'll be looking at are CPU usage and latency. So gRPC does more than just like hammer your server with requests. It also gives you like a window into what's happening to your system with some visuals and like charts, and to make things a little bit more digestible. So the first insight, first challenge we ran into was, how do we dynamically generate or obtain this client stub? There's a bunch of options to do that. Just to name a few, is like code generation, reflection, and or like giving your profile path. So for code generation, we just ask that the user generate client server code from the protofiles and share that with us. And then that could be like really, that you could get like, the pros of that is like you could get compiled time checks, which can catch errors early. The cons, it just adds an extra step. You could lead to more like versioning challenges. The second is reflection. The server would have to have the reflection on it, which is not always the case. And then the last method, which is what we went with, is the profile path. It's pretty simple. You just put your file path in a config file for us, and then we just use that to create the client stub. So why is this nice? It's super simple. It's easier to manage different versions of your protofiles. You can have like dynamic updates, so switching protofiles without recompiling the tool. So this is like an example of a simple config. The first one there's a couple of things here. The first one being duration, so just like the time defined of the load test. And then the path to your profile, your service name, the package name, method name. This is just pulled straight from the official GitHub repo for gRPC, so this might look familiar. And then this is just like the options, the flags that are in the CLI tool, if you don't define it in the YAML file. But if you do define a YAML file, it's a little bit less verbose when you do the CLI tool. So the second insight we had was observability. Like the previous presentation just said, there's like 3 pillars that observability stands on, right? The first one being logs. These are just like the detailed descriptions of what the system is doing in an environment. So in gRPC, this would be things like client-server communication, request-response payloads, any errors or exceptions. Metrics are going to be the quantitative data that you give, and then you can aggregate that to get a sense of how your system is performing. Traces, this lets you track your request journey through various services and systems. And then to solve this observability, we just use gRPC interceptors. And then, so obviously there's a lot of observability and monitoring tools. Like, why would we not just use Prometheus or like Grafana and all these other tools? It's not because they're not great. It's because, well, they are, but it's kind of like an overkill for something that could be like really simple or have a really simple process, right? If you just want to do a simple load test, you don't really need to like hold on Prometheus and then like create a Grafana dashboard just for that. And then the third and final insight that we had was concurrency. Given that Node has a single threaded event loop, we were just trying to figure out how to load test our server and how to simulate multiple concurrent requests. Well, it's not brand new, but recently Node has released worker threads that you can access. So we use that. So we just spun up a bunch of clusters, and each cluster would spin up worker threads, and we would use that to simulate a load test to our server. And then so what we did was, for data collection, was each worker thread would use the inter-thread communication and pass messages between each other and then back to the main thread to aggregate all that data. So these would be things like CPU usage, like I said, latency and throughput. Another interesting metric that we used was event loop utilization. Trevor Norris actually talks about this and can explain it way better than me. But to summarize his article, he said CPU is no longer enough of a measurement to scale applications. There are other factors such as garbage collection, crypto, and other tasks placed in libuv's thread pool, and that can increase CPU usage in a way that is not indicative of the app's overall health. So the event loop is just like basically a timer for when the event loop is idle or when it's active, and just like a ratio of that. And the nice thing about that is you can use that per thread because it's a thread safe method. So you don't have to worry about any memory leaks with that and whatnot. So, and because each worker has its own V8 instance and event loop, so you can track each instance's event loop utilization like ratio, right? All right, time for a demo. Mhm. All right, so I'm already in my like file path, right? So I'm just gonna start my server. Super simple command. npm run gRPC server. It's gonna start on 50,051, and then I have a script ready to run my load test. So it's gonna ask. This is a gRPC load balance tester. It's gonna ask you how many clusters you want based on the amount of cores in your computer. Mine has 10, so I'll just put 10. How many worker threads per cluster? Recommended 1 because you don't want to overload the core, or else it's not really optimal. And in this part, you can put how many you want. Like if I put like 500, so it will just like load test that server. So there's like 5,000 calls to that server, like, and then it'll create an HTML file for you. So I don't want to like show all my, wow. It creates it right here. I call it dash HTML. You can call it whatever you want. And then, so this is kind of hard to read, but it's pretty basic stuff, like your CPU usage. Obviously, it's going to be really high. We just use like all the cores in my computer to load test. But what we're looking for is the screen part right here, especially like the y-axis on the right over here is the percentage that the event loop is utilized like over that time. So naturally, like if you have like you want to test like your service and your CPU usage is like high, but your event loop utilization ratio is not necessarily that high, that doesn't mean that you need to scale up necessarily, because your event loop is probably blocked or not being optimized. You can't see it right here because I don't have this data doesn't show that, but that's kind of what that whole idea is. Let's see, let's go back to my slides. Well, yeah, that's pretty much it. Oh, so what's next? Well, that was only unary testing. We're trying to make the other streamings as for testing as well. Always open for feedback and contributions, of course. And does anyone have any questions?
The metrics that you showed, are those showing the utilization on the client that's performing the test or on the server that's receiving the load?
Yeah, that's a good question. So I was actually like trying to figure that part out because it is all ran on my computer, so I'm not completely sure. Because I believe it's on the server, the way I set it up, but I have to look into that more because I have event loop metrics being recorded on both sides actually. Yeah.
If they were a separate machine, what would
You'd be the server side, yeah.
I had a question. Could you use this for really big stress testing? Like, have you thought of that? Like, utilize 10 machines that would all connect, or that's outside of your scope?
I've thought about it, but I haven't tried it.
Okay.
Yeah.
Okay.
This is for NPM, right? Yeah. So any plant or any, can you maybe add tools for similar tools for Golang?
Oh, sorry, what was that?
Any similar tool or any, do you plan to support Golang in future?
Go.
Or suggest-
Go? I mean, it should be like language agnostic, right? It should be able to like load test other servers in other languages. I haven't tried that yet, to be honest. But yeah, I'm definitely gonna on the roadmap.